And can you see our normal screen?
Yes.
Yes.
Okay, perfect. I couldn't get my other computer to come up so that I could double check. So Teresa 2 is not with us today. All right, that's okay. I hope you guys did get my announcement about the reviews for your 1105 and your upcoming test. Sorry about that. Let me cut off my email.
Oh, I have a question. As far as the scrap paper goes, you can just use like blank printing paper, right?
I'm sorry, I didn't hear you.
Oh, do you have to use a specific type of scratch paper for this class, or can I just use my printer paper?
Oh, you can use any kind that you choose. If just as long as it's blank when you start, it can have lines, it can be the grids, whatever you prefer. You should just show it when you show your room scan
Yes.
with honor lock, and that's fine.
So it's 15 questions. So all right. So just show each individual piece of paper. All right. Thank you.
Right, and you don't have to have 15 pieces of paper. You know, just whatever you like, and just kind of hold it up. You know, it's
And you've already answered my last question. I was going to ask if we go over some stuff in 2.5B, but I see it right there.
okay. Yes, this one is a request, and that's why I wrote it, because if I pull it up, it'll be different. And we still have some more material to do. I just wanted to get the review information out there so that you guys could catch all of those if you wanted to do them. And hopefully everyone will at least do the, started to say Pearson, it's not Pearson, the My Open Math review.
One quick question.
Yes.
I also saw, I printed both of them. There's the My Open Math, and then there was two different reviews. Like not just My Open Math, there was two separate ones that were in there. Should we do all three of them?
Do as much as you feel that you need.
Okay.
I give bonus points for the My Open Math review because it's easy for me to see who did it. It also, your test comes from the same bank, so I think that one's the most valuable to you. The ASC review, a lot of students like that, and that's the one that you can watch it as a recording, or you can go in that session, which I think was yesterday. But you could still do the recording. I give 1 point for that one if you do that one. That one, it's shorter than your software review. It should just be like an hour. And just the other one is, it's a paper review in your documents, and it has matching videos. Just if you feel uncomfortable. So after you've done, you know, one review, if you feel good, then that's enough. But if you need more, I just wanted to make sure you know it's there.
Okay, and the My Open Math, is that the one that we scanned those to you?
No, you don't have to scan them. I will get them. Your test is what you will scan pages for me.
Okay.
Yeah. So as you take your test, you will write the problems on your paper, number them. And when you're done with your test and you've submitted, and you can even wait until you log out of Honor Lock, then scan your paper and upload it into Blackboard for me.
Okay. One more thing. I watched that video yesterday. Is that, are you able to see it when we type in our name and our ID number?
They will send me a list of everyone who has logged in. So make sure, I think it asks you to do a sign in or something.
Yeah. It's
Okay.
like first, last, and ID number.
Okay, good. Did you find it helpful?
Yeah.
Okay.
I liked it.
All right. Very good. Very good. Any other questions? All right. And we'll still have one more session before your test is due. Your test, I believe, is the 30th. I can't switch to that page now. but that would be by midnight, and it will close. So, you know, allow yourself enough time. Don't start it at 11:45. That's not enough time. All right. Okay, so let's do some problems. So this one is from 2.5b, and it is an absolute value equation. Your first rule is isolate the absolute. So you need to take off this 5. You're going to add a 5 to both sides. And then divide by 2. So that's going to give us 6 over here. I'm going to just do that. Right? And once your absolute is isolated, you will make 2 cases. So it will either be positive 6 or it will be negative 6. And then you're going to solve. These are linear equations, but they have a fraction. So we're going to clear the fraction. If you want to take the 3 off first, you can. Nothing wrong with that because it doesn't have fractions. So if you want to do this, that's okay before you clear the fraction. Or you could clear the fraction. Right? And so now I'm going to multiply by 4 because I don't want to deal with that fraction. And just don't lose your sign. You still have a negative b here equals 12. And so you'll need to divide out that negative 1. So we get b equals negative 12. And this one you'll do the same way. If you chose, you could multiply by 4 here, or you can move the 3 first. I think I'll move the 3 first to have smaller numbers. So negative 1/4 b equals, like signs will add, and we'll multiply through by 4. This will cancel, so I get negative b equals negative 36, and divide by negative 1. So b equals positive 36. So you have 2 answers, negative 12 and 36. Any question there? All right. So next we have some from 2.6, and we're going to look at inequalities. First, regular inequalities, linear inequalities, and then we will go to absolute value inequalities. I want to hit some of these first questions, even though I know that you guys are probably good with linear inequalities because we've done this for a while, but you might have something new here that you're not used to. So our first question asks us for set builder notation, and this is something, when I teach at 1033, if you came through with me, I don't really concentrate on set builder notation. So we'll go through this and we'll do some graphs to make sure everything's okay. All right, so we have negative 3, 2, that is interval notation. They want us to switch to set builder notation, and set builder notation has your rule in here. So it's like you've solved and your last answer of your solution is what's going to go right here. So when we read this, this says our interval is from negative 3 to 2, so x is between those. This one is a double or compound inequality, and so the rule for it is negative 3 is less than, and it's just less than because we have parentheses x, which is less than 2. Now, it might be easier for you to do the graph first and then go to set builder, whichever is easier there. So, and for our graph, we would show -3 and we would show 2, x is in between. And this software requires open and closed circles. So no equals underneath is an open circle. So that is what we should get in our work. I will type those in. So if that is where an issue comes up, we will see it together. All right, so I want -3. And I'm going to use this inequality thing. You also could use just greater than and less than from your keyboard if you wanted. So less is less than x, which is less than 2. Right? And for the graph, and I don't see anything to blow that up bigger, I'm going to put the endpoints on first, and I need to choose open circle, -3 and 2. And then we're going to connect those. You do want to make sure you get all the way up to this point, and you don't want to go past the other point, but you want to make sure that there's not any white space in there, because it will mark you wrong if you're not quite up to it. And I'm going to submit just to see if it likes what I entered. Okay, good. All right, so we'll look at another one.
Why do we want open dot?
Because there was no equals underneath the symbol. Let's see if I can go back. Right? So we had parentheses. Parentheses is the same as open dot. Brackets is the same as solid.
Okay.
Okay. Right. And so this one also has a parentheses. This is going to be one of your ones that goes forever. So our interval notation says it's from -infinity to -6. And so we want to describe that a different way, right? So it says x is less than -6. This is as far up as you get to go. That's the rightmost point. So x is less than -6. That's going to be the rule part for the interval notation. Set of all x such that x is less than -6. And for our graph, this one also is an open circle, parentheses. This is the one you look at with the number. And so we had no equals underneath, so that will be an open circle. And it is over here. It goes forever that way. All right, and we'll type those into to see if we get everything okay. So I have x, and I am going to do the inequality symbol, less than -6. And on my graph, I'll do open circle, -6. And when you draw this one, you want to make sure that it turns into an arrow. That is how you know you're at the end of it, so that it goes on and on. All right, number 3 is our first one where we're really interpreting a graph. All right, and it has graphed 2 lines for us, right? So the left-hand side of this inequality they have made as one line. The solid line, y equals 2 times quantity x plus 8, is represented by this solid line, right? The dotted line is the other half of the inequality, -2x minus 4, and it is this dashed line or the dotted line. Right, so we're comparing those, and what we want to know is when is the solid line, because it represents this side, when is it larger or higher than the dashed one? And that we're choosing higher because it's greater than or equal to. So we want to know, when is the solid line above the dashed line? Right? And when we look at the picture, down here it's below, so we don't want that. This section here, I'm sorry I can't write on that. The computer was screaming about that, but hopefully you can see my little pointer. Can you guys see my pointer there? Maybe if I use this mouse. Can you see my mouse showing on it now? An arrow?
Yes.
Okay, good.
Yes.
Good. Because if you don't see what I'm talking about, that wouldn't help you. All right. So what we want is this piece of the line that is up here, this piece of the solid line. So when you write your interval notation, remember you're talking in terms of x. So from -5 to infinity, this piece is higher. So this side is bigger than the x, right? We are including the -5 because there is an or equals there, and that is where they cross. So we are going to start at -5 and go to infinity. That is the part that is higher than the other one, and higher because greater than or equal to. Right, and so I didn't see how it wanted this. I assume it wants interval notation. And so I want brackets first. So -5, comma, and infinity. And let's just check. All right, so we're good there. And then we can graph that solution on a number line graph. So this time you want the solid circle because we have brackets. And that is because we had the equals underneath. So solid circle, -5 to infinity.
Is the other side a different bracket on the infinity because it is greater than?
Infinity always gets a parentheses,
Okay.
and negative infinity would also. And it takes a little while to get used to this idea of looking at the graphs to get this information off. So I know that piece is new. All right, so we'll go down to some regular linear inequalities and solve. I picked just one. Number 6. And remember, you're going to isolate your variable. It's best if you isolate it on the left with inequalities because they're about order, and that makes a graph easier to do. So we'll keep the x on the left, which that's what's kind of natural here anyway. Your rule that you have to watch out for is if you multiply or divide by a negative, it flips your symbol over. So when we get to division, we'll watch out. So we're going to first add the 15. So we start isolating the x. So -5x is less than 65. And then we're going to divide. We have to divide by the sign of the coefficient. So we need to divide by a -5, which is going to make it flip. As soon as you divide that by a negative, that is going to flip over and go the other direction. So x is greater than, this will be negative and 13. All right, and so that's my solution. I usually do the number line graph first and then interval from there. X is bigger than this, so we're going to shade this side to the right. That's bigger. No equals underneath, so we will do a open circle. Sorry, I'm switching to the software. A parentheses is the same as an open circle. That's what I have been doing for you guys, right? Because that goes nicely with the interval notation. So this will be from -13 to infinity. That's what we have. So solution set, -13 to infinity. We're good there. We can draw the graph. So open circle, -13. Click this. I need to get all the way to that dot until it goes to an arrow. I'll submit. It's going to mark me wrong for the first one, but it marked me right for this one. All right. So that is just a linear inequality. Just remember, if you divide by a negative, the symbol flips. Right. Next, I went to double inequalities. So, or compound inequalities. They can be called either one. And this is when you have three parts. So two symbols. So I have -14 is less than or equal to 2x minus 4, which is less than 4. And we're going to isolate in the middle. And that is where you look to decide what to do. Whatever you do to all three places. It's like three sides. I'm going to clean up. So I have 2x is less than 8, which is less than or equal to -10. Go back in the middle and we're going to divide by 2. +2, so nothing is going to flip. The coefficient of the x determines whether anything flips. So x is less than 4 and -5 is less than that. So x is between -5 and 4. And for your interval or for your graph, it would be -5 to 4. You want the middle section. And this one has an equals. We would have done bracket or solid circle is what the software will want. This one would be a parentheses in the direction of the shading or an open circle in the software. But the brackets and parentheses are what matches your interval notation. All right. So I'll do interval. It's just a little shortcut there. And you have to make sure you pick the right one. So I want brackets and parentheses. So I have -5, comma, 4. And I need one solid circle for -5. And an open circle on 4. Now I need to connect those and I want to get all the way up to the dot. Good. So you guys remember those? All right, we'll do one more. I'll take that as a yes. All right, and this one, it just looks scary because of all those fractions. It's the same kind of question as the one we just had. All right, and step 1, we're going to clear those fractions. We really don't want to deal with those. Common denominator is going to be a 6, so we're going to do that all the way across. You have to also do the 3 for that to be a legal step. So I have negative 53. Here I have 5x minus 18. And here I have 7. And that's the only extra step. These numbers are not so nice on this one. Let's see what we get. So we're going to have to isolate in the middle. So add your 18 all 3 places. It's going to leave me 5x in here. And this side will be 25. And this one is negative 35. This one did turn out nice. We're going to divide by 5, so no flipping. And so I have negative 7 is less than x, which is less than 5. So x is between those. And these would both be open or parentheses. And we'll just check this time. Good. Any question on that one? All right, we're going to leave that topic. And we're still working with inequalities, but now we are going to have absolute value inequalities. And hopefully you guys watched your videos already and took the notes for this, because this is brand new material. And the reason those are so important is because that's where you get all your rules. I might miss something saying it here if I don't see it in every problem. All right, so it is important to have your absolute value isolated on the left side of the inequality. And I'm going to play with this one just for a minute before I get right into a rule. And you're working with the definition of absolute value, which is the distance from 0. So if we look at a number line and we show a 4, all right, we're saying whatever is in here is less than or equal to 4 units from 0. So it could be over here all the way up to the 4, but it also, remember, could be over here in this part. So when it is less than, it's going to give you a middle section here, and you can set it up as a double inequality. So z is going to be between, and this one is and then you solve. Okay, but this one is already solved. So our answer here is, and it would have had brackets or solid circle. So negative 4 to 4. But it's because the distance is less than. If it's greater than, it's going to have to be out here or out here. And we'll wait on those problems. So negative 4 to 4. All right, and the graphs are just like what we've already done once you get to this point. So I'll just show you. Negative 4 to 4, solid circles. Right. So this is one where we'll have to do a little solving work. And it says whatever is in here, in this case, 6x plus 12, the answer to that is less than or equal to 24 spaces from 0. So because it's less than, that's what makes the double inequality for your setup, and that removes your absolute value symbols. So it is between negative 24, and positive 24. And then it's like you're used to. So it's understanding your definition and your setup, and then it gets you right back into things you know. So we're going to subtract a 12. And that gives us negative 36, less than or equal to 6x, less than or equal to 12. Divide by 6, positive 6, nothing's going to flip. Right, and so our graph should be negative 6 to 2. It's in between. And brackets or solid circles on the software, right? Interval notation will be negative 6 to 2. And there you go with your graph. It's hitting at negative 6 and 2. Right, let's go to 17. They're going to make us work a little harder here. So we have negative 4 times the absolute of 6x minus 7 plus 14 is greater than 13. And so we need to isolate the absolute. And so first we'll subtract 14 from both sides. So negative 4 then 6x minus 7. And this gives us a negative 1. Right, we still need to isolate the absolute. So you're going to have to divide by negative 4. Remember, with inequalities, that's going to make your symbol flip. So we're going to divide by negative 4. This will flip over, and then it will be the case that we've been working on. So this is going to be less than now, and this is a fraction. All right, so we are less than, so the distance of whatever this is from 0 is less than, let me just double check and make sure I'm good here. We're going to look at the answer. All right. This negative is what's bothering me because it really doesn't work. And the problem is I made sign error. Yes.
You divided by 4 on the right side instead of negative 4.
That's exactly right. And that is what was, this side should be positive because of your definition. It's more than that many spaces. It can't be a negative number of spaces. Perfect. Thank you. All right. So this should be positive. So we'll fix that. That we can do. Okay. And so now we can take the absolutes off, and this will be between negative 1/4 and positive 1/4 as a double inequality. All right, and we definitely want to clear fractions here. So we're going to multiply through by 4. Has to be every piece. And this will go away. And this one will go away. And then we have to solve. And you saw the answers when I pulled them up. They're not going to be pretty. So first we're going to add 28, all three places. So that gives us 27, then 24x, which is less than 29. Going to divide by 24. Nothing is going to flip there. And you just have to watch out about reducing fractions. This one is going to reduce. What it has in common there is a 3. 3 will go into 27 9 times, and 3 into 24 will go 8. Sorry, I kept the red there. This one, 29, is a prime, so it is not going to reduce. And just you want to make sure you can reduce on your calculator if you have trouble. So if I was testing 27 over 24, on the graphing calculator, it does not have a fraction button. So you would just type it in as divide. It's going to give you a decimal. You don't want a decimal. Go under the math menu, and it's your first one, fraction. So we're going to choose that, and you have to choose it one more time, and it gives you the 9/8. So that is reducing on a graphing calculator. All right, and then from here, they just want interval notation. And you can do your number line graph if you want first. Or you can just, no, this is the lowest piece of it. So it is between 9/8 and 29/24. All right, this one looks a little scary. We better have a look at it. It's just that fraction. It actually should be easier than the other one. So it doesn't have all those things that you have to use to isolate the absolute. Your absolute is isolated, so we're ready to go. It is less than, so it's going to be that middle piece of your graph, which means set it up as a double inequality. So -1 is less than or equal to 3x minus 9 over 3, which is less than or equal to +1. Clear your fractions. So we'll multiply 3 by 3. This one gives -3. It's less than or equal to, this one cancels. 3x minus 9, less than or equal to 3. And we're good to go. So we're going to add a 9 all the way across. And this gives us 6, less than or equal to 3x, to 12. Divide by 3, nothing is going to flip because it's +3. And this one turns out nice. Right, and this one they asked us for a graph. So it's between 2 and 4. It is the middle section. And you can do brackets, or you can just go ahead and do the solid circle, whichever you prefer. And it will look like that. We're good there. And we'll do the graph just to make sure I'm doing good here. So I hit solid circle, click on the 2, click on the 4, and then you're going to color between them. Oh, have to do mouse on there. I'm trying to do my stylus. It doesn't like the stylus on there. All right. And we can check, it's going to mark me wrong for the first one because I didn't really enter the answer. 19 is our first one to look at greater than. And this one we'll kind of play around with like we did the first one to understand the definition. All right, so this is saying whatever is in here is more than 5 spaces from 0. So if you played with a number line and you show your 0, this is 5 spaces. -5 is also 5 spaces. It's going to have to be out here to get 6 spaces or 5.01 spaces. This one also, it has to be out here. So you're going to get the separate pieces. So when you set this up, this says that this u is going to be smaller than -5, so the opposite sign here. And to get this piece, and then so it's or, it's going to be bigger than 5. So these are your two cases. You can only make the double inequality when it's less than, and you're isolated and ready to go. You do make sure you're isolated, but it's more spaces, so it's going to be those outside edges. And this one's actually solved since there wasn't anything else in here to do. And for your graph, it would be parentheses or open circles. So we will put this interval notation in. Your interval notation is a little bit of work here, right? Because you have to do this piece. So we are going from -infinity to -5. And we're going to have to do a union. Then we're going to do 5 to infinity. Right, and we will type that in. So I'm using interval notation, and I have parentheses. So -infinity, comma, -5, right? And then I'll click outside that, and then I want this u for union. And then I will do parentheses again. So 5, comma, infinity. Because they're two separate pieces. You can see on the graph they're separate. It's this end, this end. Any question there? So mainly be careful putting your interval notation in. You know, you don't want to mess up with a bracket or parentheses there because that's a lot of typing. All right, let's see about the graph on this one. So this piece, so it's coming up to -5, and that is an open circle. So we're going to go here, and that is going to be this piece, and it turns to an arrow. And then the other end, I want an open circle, 5, and then I'm going to go this way. Should be good. All right, so that's your basic one. Now we'll put some more pieces on there. What's 19? Next, I picked 22. This one is going, the reason I skipped and went on down, this one goes back to the other kind, all right? And we've practiced a few of these. This one would be this kind. We could do 20, right? That way we won't have so much going on it. Pretty good for time. All right, so it'll only have one piece of solving when we get in there. But our absolute is isolated on the left. That's what we need. But we say whatever is in here is more than 3 spaces from 0. So that's going to be your outside edge. So as you remove your absolutes, this whole thing is going to be less than -3, or it's going to be more than positive 3, right? Because whatever this is more than 3 spaces. It's going to be here or here. Now, that's not going to be your final graph. That is just, sometimes I will do that just to remember which way it looks so I know what kind of answers I'm getting. Now you actually have to solve these. And so you're going to add your 2. So this is going to be x is less than -1. And this one, add the 2. So x is greater than 5. So that's what the numbers here will be now. So for our number line graph, we want this end, and there is no equals. So I'm going to do open circles or parentheses, right? And so it's going to be from -infinity to -1 and union. Then it's going to start again at 5 to infinity. All right, and we'll type that in. So I'm doing interval just to save me some time. And I have parentheses and parentheses. So the first one, -infinity, comma, -1. And I have a union, and parentheses again, 5, comma, infinity. My graph, so I'm going to do open circle, -1. I'm going to go this way. And then I'm going to do an open circle at 5. And go this way. Good. All right. So 21 is the other kind, right? It's less than. So you have to watch your symbols on these. So it goes into a double inequality. We'll skip it. We did a few of these. 22 looks like it might be that kind, but it actually is going to flip your symbol when you divide by this -8. So we'll go ahead and go through this one. Looks like it's going to have a few steps for us. Oops. All right, so first step is we need to isolate this absolute. So take off your 13. So -8, absolute of 7x minus 5 is less than -9. And we have to divide by -8. That is what's going to make it flip and be the other kind. So we still have the absolute symbols at this point. It's going to be more than. 2 negatives here with division gives us positive. And we have a fraction. All right, so it's more than this many spaces. It's going to be your outside edges. So as we take the absolutes off, this will be less than -9/8, or it will be more than +9/8. And we'll solve. I am going to clear the fraction first because I don't want to get common denominators there. So I'm going to multiply through by 8, which will cancel this one, just gives a little bit bigger numbers. 56x minus 40 is less than -9. And so we're going to add 40. So 56x is less than 31 and divide by 56. right? And I do not think that will reduce. So x is less than 31 over 56, right? Other one, clear your fraction, multiply 3 by 8. So we have 56x, let's do a line here, minus 40 is greater than positive 9. So we'll add the 40. So 56x is greater than 49. Divide by 56. And this one I believe will reduce because 49 and 56 both have a 7 in them. So I'm going to reduce there, or I could take one more line and then reduce. So 7 will go into 49 7 times, and 7 into 56 will go 8 times. So I have, it's less than 31 over 56. And it's more than 7/8. And they should not ask us to graph this. Okay, which is a good thing. So negative infinity to 31 over 56 with parentheses, union 7/8 to infinity. And I'm just going to look at that since we've typed a few. Negative infinity, we use parentheses, 31 over 56, good. There's your u, 7/8 to infinity. All right, let's try another one. These are really mixed. This one is a much easier problem than the one we just looked at. So absolute is isolated on the left, which is key. It's more than 9 spaces, so it can be below -9 or above +9. So as we take the absolutes off, this is less than -9, or it is greater than +9, and we're good to go. Add your 6. So 3x is less than -3. Divide by 3, nothing flips. X is less than -1. This one, subtract your 6. 3x is greater than 3. Divide by 3. X is greater than 1. So -1 and +1, and it will be here, and it will be here. So negative infinity to -1, union 1 to infinity. Oh no, I just lost my question. There we go. All right, so I'm not going to type this all in. We'll just look. Whoops.
Yeah, I was going to say, Professor, the signs on the first part were addition instead
Right
of
here.
subtraction.
Right here. And that wouldn't have even, no, I set up in that's okay. Tell me again where I missed it.
It's the 3x plus 6 is less than -9. You added to the
Yes.
6.
I see. Thank you. Could not do that. You have to subtract 6 there. You guys can stop me as I go if I do something like that. All right. 9 and 6 is 15. Divide by 3, so x is less than -5. All right, I did this one okay. All right, so this end is wrong. Look good now? Better. Okay. And that's why I always check, because I could definitely make an error like that. And that was a silly little error. Okay, I would definitely know if I was focusing just on that piece so much that that was wrong to do what I did. All right. We'll skip the graph. You can look at the graph. So it goes from -5 down and from 1 up. All right. So I have one more off of this section, and that is 25. And this is interpreting a graph again. Right. And so what we're going to end up looking at, we're looking at two different expressions here. We have one equation, which is y equals the absolute of x minus 1 minus 2, right? And that piece is the left-hand side of this inequality. So this is our inequality. And this one is the solid line. So your V, absolute value makes a V graph, right? The right-hand side that they're putting on here is this other line. So they're saying y equals 2 would represent just this half, which is your dashed line, right? And they want us to know when the solid line, which represents this side, so this is the solid line, this is the dashed line on our picture, right? And we're looking at less than. So when is the solid part of the solid graph below the dashed line? And so it is this part down here. Let me do it with the mouse so you'll be sure to see. All right, show me the mouse. All right, so it starts right here, and it's this part down here, this bottom of the V. And I need to make that a little bit bigger on my screen. Yeah, that's better. All right, so it is this bottom of the V. It starts at -3. So from there to 5, we are below, and we don't want the ends because there's no equals underneath this. So we want -3 to 5. That's the part that is below. If they asked greater than, it would have been these other two ends. Yes, go ahead.
If it's we would still write the negative 3 and 5. It wouldn't be like 1 over like -2 and 4, since it's not like equal to. Like it would just, all it would be was just parentheses instead of the I forget what they're called.
The brackets.
Yes.
Yeah,
Thank you.
It would just be the parentheses.
Okay. Thank you.
Let's look at what they want for an answer. They want interval notation, so they're just going to want -3 and 5. So we can check. And here then, of course, you would do your open circle. -3 and 5. And we would connect. And We can check it. It'll mark me wrong for the first one. But the graph was good. Now, I want to just go ahead and do this one the algebraic way. We solved this inequality with graphing, and we looked at the left-hand side and we looked at the right-hand side as pictures, and then we could answer with the inequality of which was below. But we have been solving it algebraically, and I want you to see that when we do, you're going to get the same answer. Right? So I'm going to need more space here. So let's see. Let me move this up so I will have the original. Because I got to move this down to get more space. All right. So if we're going to do it algebraically, all right, first rule is isolate your absolute. So get this 2 off. So we're going to add a 2. Right, and then we're saying, well, whatever is in here is less than 4 spaces from 0. Since it's less than, it's going to be the middle piece of the graph. So it is going to be between -4 and +4. And then we solve. So we're going to add a 1. This gives us -3. It's less than x, which is less than 5. Which is the same answer that we have and would be the same graph. So that's 2 different ways to solve the problem. And that's kind of where they're getting you to go, that you can do problems in more than one, with more than one method and be correct. Right. I picked a couple from 2.1. We probably have about 5 minutes left. You guys want to go there, or you want to stop and pick that up on Thursday? Anybody have a feeling there?
I have to actually dismiss myself now, so thank you for the lesson, Professor.
Okay, let's stop there. I feel like this was a pretty heavy-duty lesson. So we will stop here, and we'll pick up 2.1 and some of your chapter review for next time. All right, so you guys have a great day. I'll hang out a few minutes. I'm going to stop this recording